Hey guys, so I'm going to go through what we looked at in class today, and this is basically going through how to work out current and voltage across different components. Now I'm using resistors, but they can be bulbs, they can be anything in a circuit. And if you're given a circuit, how do you work out the voltage across that resistor component and the current that goes through it? So we're going to start off with the simplest of the simplest, which is a simple circuit with just one component in it. So if we look here, we have a battery, 12 volt battery connected up to a 2 ohm resistor. So in this scenario, if you were asked, well, what's the current that goes through that? Okay, you're going to use Ohm's law. Now you're going to use Ohm's law for all of this. So V is equal to IR is Ohm's law. It's crucial that you remember that. You have the voltage here, you have the resistance. Now, of the whole circuit, you must know to use this if you get the voltage of the whole circuit. So the only voltage that's here is 12 volts. The total resistance of the circuit is 2 ohms. And by rearranging this, I get the current is equal to V over R. So that's the form of Ohm's law that we're going to use for the rest of this. The current then is the voltage, which is 12 volts, divided by the resistance of the whole circuit. And again, there is only one resistor here, it's 2, and that gives you 6. So because you're looking for current, it's 6 amps. So that means there is 6 amps flowing here, 6 amps through that, and 6 amps out the other side and back around. As a little exercise, I want you just to pause the video now and work out for this circuit down here, using the method I did above, what the current going through that 12 ohm resistor is. Okay, so using Ohm's law, the current is V over R, which is 6 divided by 12, which is 0.5. And again, it's always in amps, 0.5 amps, because your voltage is in volts and your resistance is in ohms. So the current always comes out as amps. Okay, that is the simplest example. So let's complicate things slightly. What if you then have I'll make this a bit bigger here. What if you have a series circuit here? Okay, so I want to know what is the current that goes through each one of these resistors here. Now, I can't just use I is equal to V over R, because if I use, say, this resistance here, in that I need to know what the actual voltage is across that. Now, I don't know that. I know that the voltage across the whole circuit is 6 volts, but I don't know the voltage across individual components. So what we do is we use our formula for finding effective resistance or total resistance, and in this case, because it is a series circuit, you're just adding them together. So this circuit acts like this circuit. Now, as I said today, when I say it acts like it, basically whatever current that flows here is going to flow here. Okay, it's identical, acts identically. So now we're back up to the scenario that we had for your exercise up here, of where we have our 6 volt battery, okay, and a total resistance of 12 ohms. So using V over R there, we know there is a current there of 0.5 amps. So bring that back over to here. There is a current here of 0.5 amps, because that is a series circuit. And again, tracing. This is a simple thing to do, but it really shows you when the current splits or when it doesn't split. If I go from one side of the battery all the way around to the other side, I have to go through both those resistors. So if I have half an amp coming out here, I have to have half an amp flowing through this resistor and half an amp flowing through this resistor. So my current through the 8 ohm resistor, 0.5 amp, the current through 4 ohm resistor, 0.5 amp. And again, that's how if I had 3 resistors, 4 resistors, 6 resistors in series, you do it exactly the same way. Okay, so little exercise for you. Pause the video and work out what the current is going through each resistor there. Okay, so the total resistance here, 18 and 12, is 30 ohms. So you have current is from Ohm's law up here, V over R. Okay, we have a voltage of 3 over a total resistance of 30 ohms, which is 1 over 10, which is 0.1 amps. So I have 0.1 amps flowing through here, through this resistor, and back up to the other side. So my current through the 18 ohm resistor, 0.1 amps, current through the 12 ohm resistor, 0.1 amps. Okay, so that's resistors or components in series. Now, what happens when they are in parallel? Well, ironically, this is actually an easier scenario, because if you look at a parallel circuit here, and again, I'm trying to find the current that goes through here and the current that goes through here. I don't need to find the overall resistance here, because if you look at this circuit, let me just change the size of this. If you look at this circuit, well, really what I have is this top part is just a simple circuit with a 4 ohm resistor connected to a 6-volt battery. This bottom part here, well, that's just another very simple circuit of a 4 ohm resistor connected to a 6-volt battery. So because in parallel, each side of the resistor is connected directly to the battery, what you know is that the voltage across that resistor, well, it's a bit of a squeeze now to put a 6 in there, but is 6 volts. The voltage across this resistor here is also 6 volts. So now I have my V and my R to work out what the current is. So down here, to get the current through the top resistor, you have a voltage across that resistor of 6 volts, and you're dividing it by the resistance of 4, and that gives you 1.5 amps. And then exact same calculation with the bottom one, 1.5 amps. Okay, so what does that look like in the circuit? Now, this question is just asking what's the current through each resistor. But if I have 1.5 amps here, let me just make this a little bigger, and I also have 1.5 amps coming in here through this resistor, well, that must mean that there was 3 amps coming from the battery up here. So that 3 amps comes down to this point, 1.5 amps goes in here, and 1.5 amps goes in here. Because they're the same resistance, they get the same current. So now we're able to find current through resistors in series and current through resistors in parallel. So let's combine that and look at this mess here. And this is much more realistic of what you're going to get in an exam at higher level. So ordinary level, they might give you something like this, but higher level, even if they give you that at ordinary level, to be honest, at a higher level, this is really what they're going to be looking at. So a circuit of where you have parallel components and a series component. So the first thing that you are going to do here is you are going to look at simplifying this. Okay, so we can see here, if I take this part, you have 2 resistors that are in parallel. So if I use my parallel formula, 1 over, I'm not going to do the calculations here, but basically 1 over R is equal to 1 over 30 plus 1 over 30. Okay, I will do the calculations. 2 over 30, that's what 1 over R is, and that gives me my effective resistance of 15. So these two can be replaced by a 15 ohm resistor, and now I have a 10 ohm and a 15 ohm in series. Well, that looks awfully familiar because that's exactly what we did up here. So you are now just back to how you did this. And how did we do that? Well, we calculated what the total current that was coming out was. So we added the two of those together. So that's going to give us a circuit that looks very simply and very simple like this. 15 and 10 is 25 ohm, and you have a 50 volt supply. So my total current in there is V over R, which is 50 over 25, which is going to be 2 amps. Now, we'll work our way back. We're not going to go straight back up here. We're going to work our way back. So we know that we have 2 amps going through this, and we have 2 amps going through this here. So first part of the question is answered. We have 2 amps going through here, but the second part of the question, we have 2 amps coming in here, but some goes up here and some go down here. Now, you might say, aha, but they're equal resistors, so they get equal current, and you'd be absolutely right. But what if they're not equal resistors? So in that case, what you can very easily do is you can work out what the voltage is across there using Ohm's law. Now, I have 2 amps going through here, 2 amps going through here. Why? Because it's a series circuit. So I now have resistance and current for this resistor. So I can work out my voltage from Ohm's law. V is equal to IR. So my current is 2, my resistance is 15, so my voltage there is 30 volts. Okay, so now I know that there is 30 volts across there. So now come back up to this. So I have now, if I want to draw on this even more, the voltage across each of, there's a lot of 30s going on here, but this isn't going to be the way it is in all the questions that you do. You have 30 volts across a 30 ohm resistor. So my current is my voltage divided by my resistance, 30 volts across 30 ohms, that's 1 amp, which is exactly what you knew because the 2 amps splits, one here and one here. But as I said, you won't always have it as simple as that in the exam. Okay, the joy of the video is that you can rewind and go back over whatever isn't making any sense to you. I will give you a very simple question here to do with some very messy numbers, but it is going to be something similar to what I did above. And I want you to do this for homework. So we'll assume that we have a 12 volt battery here. We have 10 ohms, 20 ohms, and 20 ohms here, resistors, and we have a 40 ohm resistor over here. So I want you to find the current through each one of those resistors, and I am going to label them resistor 1, 2, 3, and 4. And that is your homework, to go through the current, find the current through each one of those. Okay, thanks guys.